All right, let's look at the topic 3 review. Question number 1 says, what is a rule for the translation of triangle RST? Select all that apply. So be careful with the select all that applies. It may be 1, 2, 3, 4. Well, 4 would be the limit here. So we have to first determine where do we start and where do we end up. So I'm just going to look at my letters. Here I have T, here I have T prime. That means I'm starting with this triangle and I'm moving it this way. In my directions it says it's going to be a translation, so I'm going to make sure that the orientation does not change. That's definitely true. R is on the top left, R prime top left, S and S prime are in the same place if I were to translate it, as well as T and T prime. So I know that I'm going to be moving to the right as well as down. So I just want to ask how far to the right and how far down, and that's going to give me my X and my Y. So if I come in here, and let's just do it this way. So here's the point where it stops going right and it starts going down. So let's see how far we have to travel. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So going to the right is positive, going down is negative. So this means my translation follows the rule 5, negative 5. So that is definitely this one.
It's all over, boys. It's all over.
But because this is a translation, we can look at it verbally as well. Here we have 5 units down, 5 units right. That's exactly what we have here. So I would also select this. Now what's going on with C and D? C and D are enticing answers because they're the opposite of what we actually did, right? 5 units up, 5 units left. What they're trying to do here is evaluate whether you fully understand your prime notation. If you were going from prime to just point T, you would select C and D. But we know that's not the case. We know we start with our pre-image, and that just has points RST, and then we're moving this way to increase our prime once we stop. So A and B would be our overall answer. All right, let's knock out 2 through 5 relatively quickly. These are just our basic transformations that we've been working with. Let's get our ink back to black. So the reflection across the x-axis of Qrst. X-axis is, of course, our horizontal axis. Let's get away from our black ink. That's our x-axis. So all I really need to ask myself is how far are each of these points from the x-axis, and then we just flip it over the other side the same distance. Here I have 2, so I go 1, 2. This will be my T prime. I'm not going to put the squiggles here just so it's easier to see. So I'm 2 above, so I need to be 2 below. This is going to be T prime. S is 1 below, so I'm going to go 1 above. This gives me S prime. Q is 1, 2, 3, 4 above, so I need to be 4 below. 1, 2, 3, 4. That's my Q prime. And R is 2 below, so it needs to be 2 above. And then just connect my dots. I'm going to go in alphabetical order because I can see that they go in alphabetical order, so I'll be less likely to make a mistake and cross in the wrong spot. Q to R, R to S, S to T, and Q back here. Does that look like the same shape? It does to me. I can see that this is the same distance from here to here as it is from here to here. So it just flips itself over and we are good to go. Now, of course, you're going to have to label these points. This is the review. We're not in Algebra 1 or pre-algebra, so I'm not going to label each point. We know how to find the coordinates. I guess just to be nice, I'll do this 1 for R. Ooh, if I could see. This would be 0, 0 here. So R would be 3, 2. And then you can plug in or find the rest of your points from there. To rotate it 180 degrees, we know from our lesson that the rotation is the negation of the x and the negation of the y coordinate. Let's check that though before we move on. We know this. Where is 0, 0? Here. We know this is 0, 0. So I'm just going to plug in the point 1, 0. And if I know if it's 180 degree rotation, I should end up here. Well, that's exactly what I would get. I would end up with -1 and 0. So I have that set up correctly. And then for each of these, I'm just going to take whatever their points are and negate them. So this is 3, -2. To rotate this 180 degrees, I'm going to end up at -3, +2. So this is my origin. So I'm going to go 1, 2, 3, 1, 2. And just like we can see, we're starting in quadrant 4, and just like we said in class, if you're going 180 degrees, you're going to go 2 quadrants over and find your point in there. That helps us know that we've done this right. So that would be our first one. Let's do one more. Let's do one that is a little bit different. Let's talk about, here's 0, 0, so let's do -2, +2. So for this one, if I follow this rule here, I would end up with -2, comma, -2, and this would just become 2, -2. So my t, again, would start in quadrant 2, 90 degrees would bring it to 3, 180 degrees would bring it to quadrant 4. Quadrant 4 is definitely a positive x, negative y. 2, -2 is going to be right there. That is a 180 degree rotation for that one. You can do the other 2 points the same way. The translation of Qrst, we're going to go 2 to the left and down 3. 2 to the left would be from any of these points. 1, 2, 1, 2, 3. This would be my t prime. Again, 2 to the left, down 3. 1, 2, 3. Oh, 2 to the left, and the color didn't change, so let's go ahead and get that done. 2 left, down 3. 1, 2. 1, 2, 3. This is my S prime. And we just keep doing this until we have all of them. 2 to the left, down 3. And so on. Then we can retrace our shape, our polygon, and have our final answer. Now our last one's a glide reflection. This is an important one, so we'll do the whole thing for this one because this has 2 steps, and we do these right to left. So we translate first, then reflect. That's supposed to say second. Hold on. All right. So let's just do it with 1 point, and you can apply the same thing with any of the other points. I'm going to do this with Q. So Q, I need to translate 3 to the right, and don't move it up or down. Instead of pointing that arrow. And then no change for my Y. So 1, 2, 3. Here is Q prime. And now I need to reflect it over the y-axis. So let's label that. Let's actually do it in purple. The y-axis would be right here. So how many units is... Here's a major error I made. We're definitely not going to write that prime yet because this is a composition. So this is just the... I call it the shadow image. This is just the first step in this glide reflection. Now we know how far away are we from Q. Q from y-axis, so that's 1, 2, 3, 4. It's 4 to the right. That means it needs to be 4 to the left. 1, 2, 3, 4. And this gives me Q prime. That's where we're actually going to stop. We're going to do the same thing. We're just always going to move it 3 to the right and then flip it over the y-axis. So let's do T because this one's going to be weird. It's going to cross over and then it's going to bounce right back. Because, let's see it, 3 to the right That's 1, 2, 3. That's our shadow image, and then we got to flip it over the y-axis. Well, it's 1 away, so it needs to be 1 away. T prime is going to end up right there. Alright, so you can pause the video here to check your coordinates for 2 through 5. I have it on the screen for you. And let's move on to question 6. So if you like any questions on this test, that's going to be question 6 and question 7. Now be careful when you're answering these on the actual test, because you might make a little mistake here. So let's look at a couple of things. If I look at every vertex, I'm just going to make an arrow in which way they're pointing. I'm not going to do this last one because we can see these are definitely just the mirror image of each other. This one slightly up and to the left. This one is slightly up and to the right. These are pointing in direct mirror opposition of each other. So I can say that this is without a doubt a reflection. And I can say my line of reflection is about, let's do it an actual line. Line of reflection would be right here and about the center of the two. And that's definitely a reflection. Here I can see that my orientation is preserved. The way that all my vertices are pointing maintains the same. I even have this concave piece. Concave means it points inwards instead of outwards. We'll learn a lot more about that in the future. But this is without a doubt a translation. And let me just go ahead and put reflection. So this is going from here to here, here to here. And we can see that that's the same distance if we really wanted to pull out a ruler or something and do that. Next we have, which of the descriptions is true for the graph? Now here, the first thing I'm going to do before I even look at my graph is I want to see what circles, or sorry, what triangles are we looking at here? And it looks like for every case, we're looking at A prime, B prime, C prime to A double prime, B double prime, C double prime. Oh. There's not a single one of these that's not A prime, B prime, C prime to A double prime. So that's a good sign that one of these triangles is irrelevant on this. So let me go ahead and look at what, or kind of show you what I mean by one of them's irrelevant. So we're starting with A prime and we're moving to A double prime. That means I don't need anything in the pre-image. The pre-image is unnecessary for what this is asking. So let's ignore the pre-image and let's look at some of the things that are happening. To go from A prime to B prime, or A prime, B prime, C prime to A double prime, B double prime, C double prime, is it true that we just take a translation 5 to the left? Well, let's see. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2. Let's start that one over. 1, 2, 3, 4, 5. So this looks like a possible answer. Notice that I always counted from A prime, B prime, C prime over to the double prime. And that's just so I don't make any mistakes there. That's possible. Now this one, a reflection over the x-axis. I can rule this one out immediately because the orientation of my triangle never changes. C is always on top, B is always on the farthest left, A is always farthest to the right. There's without a doubt no reflection here. A reflection across the x-axis would put my triangle to this one. That was our pre-image. So our pre-image to our prime, our first prime, was this. And this is what they're trying to do. Notice this is the same. if you were to pick this one during the test, it's because you didn't consider the composition, and what you didn't look at were the notations here. Triangle ABC was a glide reflection by flipping it over the x-axis, then sliding it to the left. But this is not okay with the prime, so this one is absolutely ruled out. A prime, B prime, C prime flipped over the x-axis. Again, we have no change in orientation, so we're not even going to entertain that one. And A prime, B prime, C prime rotated 90 degrees. Well, that's positive 90, and we know very well that rotating any of these positive 90 degrees is going to take us from the fourth to the first quadrant. So that could be taking C prime back to its pre-image. So that one's out of the question, and we are going to stick with our original possible answer, but we have also checked all possible, and we are going to say that A is in fact the correct answer. All right, guys, so question 9. If the point P prime is at -3, 2, and it is the image of point P, which is at 3, 8, under a translation, what is the image of 0, -6 under the same translations? Sorry, I looked at the wrong screen, and I thought, oh no, I'm still showing question number 6. So our first thing to do is what translation took P to P prime, or we don't need that T there, right? Because it's a translation of P to P prime. So how did I go from 3, 8 to -3, 2? Oh, to get from, so I'm just going to ask myself, plus or minus, actually we can just do plus, x, y, to get to -3, 2. Well, I would need here, this would be 3 plus x equals -3. Subtract 3 from both sides, x equals -6. So right now, I know my change in my x is 6 to the left. And then to do the same here, I would say 8 plus y equals 2. Subtract 8 from both sides, y is equal to -6. So it looks like my translation is just going to be -6, -6. But that's not my answer, right? That's just the translation that we have to apply to this. So let's read the question before we do that. This is a reading test for this one, by far. What is the image of 0, -6? So we're trying to produce the image. That makes this here the pre-image. So what we're doing now, I'm going to take it over here, is applying the translation of -6, -6 to this point 0, -6. And all we have to do now is add these together. Here's my x coordinate coming in here. Here's my y coordinate. This is going to give me -6, -12. And we can see that that is option D. So let's just talk about this one more time. I started at 3, 8 because I don't have any prime notation. I'm just going to clear the whole thing. We started at 3, 8, and we asked what translation would force me back to here. That is -6, -6. So P, let's do it. So the translation of -6, -6 of point P will yield P prime. And then we can apply that same rule. We're just going to call this R. Translate R to get R prime, and R prime would be at this, because we're going to take it left 6, down 6. Let's move to question 10. All right, we're in the symmetry section now. So it wants to know which capital letters have one or more lines of symmetry. Not rotational symmetry, but lines of symmetry. These are those reflection symmetries. Where can I draw lines through these so that they map onto themselves perfectly? I'm going to go with the bright green here, and I'm also going to zoom in because I think it's a little easier to kind of solve these when we can see them that much more clearly. So, oh, where's my meeting control? So let's go annotate, annotate. So if I take my straight line tool and I look at V, what I'm seeing immediately is that will definitely fold it onto itself, right? I don't really see anything else here, but it doesn't matter because I have one line. Which capital letters have one or more? As soon as I prove one, I don't have to sit here and think about it. So I'm definitely going to go with A. Now I'm going to look at B. Let's do B in a different color. So not the letter B, but how about the letter M? Can I flip it over? This way is a common way I see it on the test, but if we think about this part's going to come up here, and it's not going to quite be perfectly mapped onto itself. So that's not the way to do it. Can't do it this way because this won't fold over onto itself. This is still our problem area. These are our problem areas. But what I can do is fold it on itself just like that. And again, we have a line of symmetry. We can reflect right over it. Up next, we have the letter N. Now, I am not seeing any way that I can fold this in on itself so that it would line up with itself perfectly. The M works because we have this valley or this V in the middle. V, as we've already shown, is symmetric, right? And if I fold my V over, it's going to bring this line and this line with it. We don't have that corresponding piece here, right? There's no way I can draw through this diagonal to get it to fold onto itself unless I go like this. But then I see my problem becomes this section and this section won't quite line up with each other. I'll end up with more like a very boxy U, a little bit of something extra. All right, here's one where no matter what, I can just randomly start drawing through the center and I will always get some sort of symmetry out of this. Your circle is your perfect symmetrical polygon object. So for this one, A, B, and D are without a doubt correct. Let's move on to number 11. Point T is at -6, 4. What are the coordinates of point T after where we reflect over the x-axis and then compose it with the reflection across the y-axis? Notice, since I am thinking about doing this actual work, I'm reading it right to left so I can work it right to left. I want to get away from that confusion. I do not ever, realistically, don't want to read these left to right. I want to x-axis, then y-axis reflect. So let me zoom out a little bit so we have a little bit more of a work area. And we get a little preview there that this whole review is about to get a whole lot easier. So let's just do this with our rules that we came up with in class. I'm going to do it over here. So T is at -6, 4, and I need to flip it over the x-axis. If I'm going over the x-axis, that means I negate my y. So I'm going to call this TI for intermediary step, that middle step. I'm only doing the right side, so I'm not actually increasing my notation. I'm going to end up with -6, -4. And then I'm going to do the rest of this composition where I'm flipping it over the y-axis. Well, let's do this one. I'm going over the y-axis. That means I'm going to start here and I'm going to come this way. So now I have to negate my x. So once I've done both of my transformations under this composition, well, let's go ahead and negate my x. I should get 6, -4. Now I have my answer, right? Remember, this right here stands for T intermediary, and that just means I can't increase my notation yet because I haven't finished this composition of rigid motions. We only increase our prime once our composition chain has run its course and we have our final resting spot. So for this one, we have our final answer of 6, -4. Number 12, the rule translate 4 to the right, down 1 is used for point 2, -7. Where is the translated point in the coordinate system? All right. So what I'm imagining they are aiming to do here is just kind of get our Algebra 1 understanding back under our feet. I don't know what. They're just testing to see if we remember our quadrants, right? And then if we can properly move it. So remember, quadrant 1 is in the top right. That's where everything is positive, positive. Quadrant 2 is when you have negative, positive. Quadrant 3 is negative, negative. And quadrant 4 is positive, negative. Now, I did all that just because some of us might not remember 1, 2, 3, 4, but we can see the positive, negative combination, or the positive, positive, or the negative, negative combination. And it kind of provides some insight into rotations, right? Look at 1 to 3. Those are 180 degrees apart. Look at 2 and 4. They're 180 degrees apart, and they follow that rule. You just negate each one. So maybe that would have been a nice little proof to show you. I wouldn't call it a proof. Just a little proposition there. So it's saying that I am starting with 2, -7. And I'm applying this translation. So I'm going to add 4 and subtract 1. And this is going to end up at 6, -8. So now I see I have a positive and a negative. Well, if I go back to my chart, this positive-negative combination is always in quadrant 4. So I'm going to mark that as quadrant 4. My final resting place at 6, -8. Number 13 wants to know, which of the following descriptions apply to the transformation? Select all that are correct. So this is a clue that we are going to have more than one. And I'm going to tell you right now what you want to do to make sure you're safe here and you're doing this right is please, 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 please identify your pre-image. And remember, I know this is my pre-image because there's no prime notation and my image. Remember, I started with my pre-image and I'm moving to my image. So I just need to know how much did it move. Now, I'm going to look really quick and just confirm that all 4 options are related to rigid motions. All of these are straight up translations. So there's not going to be a question where you can't answer it because it's not a rigid motion. So I just need to find any combination that's true. And before I really try and count these out, let's talk about what this means. A means go left 8 and don't go up or down. This says go 8 units down. These are not the same. However, A and C say the exact same thing. So if I understand that one of these is right, then the other one's automatically right because it's saying the same thing. Then if I look at my other option, I have 8 units down, and this means go down 8 units. So if I can count this out and see that B is right, or I can see that D is right based on my preference, then I can automatically apply the other answer as correct as well. So now let's look at it. And I'm not really going to do any math on this one. We went 8 left, right? Every one of these numbers is 8. The image definitely moved to the left. We don't have to count it out. But since I know we went 8 left, I'm going to choose A and C. Now, if you guys are like I was, or well, am, whenever I take a test, I can apply this test taking strategy. I can say this all is good. But I'm not going to want to hit submit until I see it for myself. So I'm just going to pick one of the points. 1, 2, 3, 4, 5, 6, 7, 8. And I got -8 because going to the left on the x plane, or the x coordinate, moving left with the x axis is -8. So that is my answer. If a figure is translated with the rule -5, +3, which translation moves the image back to its original position? Think of this as if you spend $5 to make $3, right? You spend $5, or you went -5 and then you made back 3. Isn't the opposite of that gaining 5 and then losing 3? So that's how you undo it, right? I slide 5 to the left, 3 up. Now to undo that, I have to slide 3 down, 5 to the right. So we would just end up with A as our answer. Oh, 6, 7, 8, 9. So we're on 14 and 15. All right. So this is that one that you look at and go, yeah, this is easy. And then there's always that one little catch that gets you. So I'm going to do annotate. If I can bring up the tool. And I'm going to switch to the highlighter. So line L. Let's look at that one. If I fold this over that line, this is going to be a problem area for me, right? Because they're pointing inwards. If I cross this line, it's just not going to map correctly. So I'm going to go ahead and say it's not going to be L. Now this is a select all that applies, so I have to check every one to make sure. All right, I think M is an easy one to see. Straight through this line, just flip it over. This is pointing inwards, this is pointing inwards, outwards, 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 outwards. We're good to go. Another way to look at this is called concave because it kind of caves in. And these corners are called convex because they point out. So M's an easy yes. If L didn't work, N's not going to work. So I'm not even going to really explore that one. But I do want to look at O. This is just saying if I grab the bottom, fold it up to the top, will this map onto itself? But the same reason M's work. The option M works. The option O works. So for number 15, we're definitely going to end up with B and D as our answers. Number 16. What do we have here? Stick to this, stick to this. So for 16, folding over line Q, that's a definite no, right? Nothing here is going to line up. This is not going to line up. This is not going to line up. So we're not going to even look at that one. R, without a doubt, if I grab it by these 2 points and I fold them down, they're going to end up here, and this will fold over in on itself. Looking at option C, that's line S. If Q doesn't work, S doesn't work. And then if we look at T, yeah, this is going to work. This is going to fold over to here. This is going to fold over to here. And this is going to fold over to here. Everything else is exactly the mirror image of itself. Very easy to see. So R and T will be our options for this one. Number 17. Well, I'm starting to see a theme here. It looks like we're just looking at the horizontal and the vertical lines to make it work. This piece and this piece are going to map onto each other. This vertex and this vertex through L will map. This one and this one will map. This one and this one will map, and that one and that one will map. So for no questions asked, L is definitely a line of reflection. Is M? No, not again. Or once again, it's not, right? There's no way that I'm folding this vertex to this vertex and this piece is going to line up somehow down there. M is out of the question. Let me go ahead and fill back in option A. And since we're still on number 17, let's look at option N. Well, not very creative here, but definitely these match up across themselves very evenly. And O is another no. So for 17, we're looking at lines L and N. All right, something a little bit different. Even without the annotation tool, we can go ahead and say that L doesn't work. This point's going to come down here, won't map onto itself. M, if I fold this guy, this is just going to flip up to over here, can't map onto itself. And again, N, this flips over here, hasn't mapped onto itself. So number 18, we have definitely the choice of none of these working for lines of symmetry. Now, which words have horizontal reflection symmetry? Horizontal means flat or zero slope. So which of these words can I draw this line through and get symmetry? So it could be this way, this way, this way, and this way. So let's start with, option B, which is pop. If I wrote this, and another way you can do this is just write it upside down. Oh. If I wrote pop upside down, I would get Bob. Bob and pop aren't the same word. This is not a one that we're going to be able to do. If I flip S upside down, I'm not very artistically inclined, so I'm not going to try and write this upside down, but you'll see that this back end piece cannot be there for it to be reflectional symmetry, and that cannot be there. So I guess what I'm saying is if I did this, oh man, and then I did, that's what an S would look like upside down, and you can see they're not the same. Yeah, it would kind of look like 52. Here, C upside down is C, H upside down is H, E upside down is E, C upside down is that, and K upside down is check. Looks exactly the same except for I don't have the handwriting they do. Here we already know that circles are always symmetric. Here we've just shown K's are symmetric, and B upside down is just B, especially in a typeface format. So our final answers for number 19 are A, B. So you have two right answers there. And last but not least, I'm going to stick with it. Last but not least, question number 20. And that's asking us, which shape is an example of rotational symmetry? So your immediate inclination, had you not had my rotation lesson, is that all of these can be rotated because I can just go 360 degrees and they map onto themselves. Or less likely and just as cheaply, we could say 0 degrees or no rotation would map it onto itself. But remember, the number one rule of rotational symmetry is that your rotation is less than 360 degrees but greater than 0 degrees. And what that means is these are barred because these do not make true statements. If I put 0 in for R, 0 is not greater than 0, so that's restricted. And 360 is not less than 360, so it's restricted. So now I have to figure out which of these shapes can I turn most of the, or almost 100% all the way around and getting it to match onto itself. I'm not a machine. I'm not an artist. If you really feel it, you can put your paper up to your monitor during the test, trace it, and then try and get it to line up. But I want you to remember this. Rotational symmetry and the number of degrees you have to turn something is derived from the number of lines of reflectional symmetry. So I'm just going to try and find reflectional symmetry through these flowers. And if I go this way, these and these are not exactly the same. This one's too short. It's not going to line up. That's not a line of reflection. If I go this way over, so we got to be careful because we don't know how to read Pearson's mind or Savas's mind. But let's see if we can convince ourselves. I'm going to say the petal on the top left and the top right aren't going to do it. And I'm not on camera right now, but I'm kind of flipping my head upside down. These petals just aren't quite there. So I'm going to go ahead and say no. But if I can't find anything, if I can't disprove the rest, I'm going to come back to this one and really look at it. B, super easy. There's no way I can draw a horizontal line through the center of B and possibly get any type of symmetry here. Just not happening. This petal is way too far off center compared to the other one. So we're going to go ahead and say there's no way there's reflectional symmetry there as well. We can also see these are slightly off. Here, again, can't do it this way. Can't do it this way. But this one looks to be identical. I'm fairly convinced that I could do that. And really, I don't need to, since I've kind of not seen it anywhere else. For any other example, even one, I'm going to go with D. Right? I can definitely tell that that is that flower split right down the middle. And because it has a line of reflectional symmetry, it has rotational symmetry. All right, that's the topic 3 review worked through. Let me know if you have any questions.